Hi there, this is the Practice Chapter 1 test, and as always I am the amazing Mr. Jansen, so away we go. If we look at the first one, we want to simplify and then solve. This is just a linear equation, so I can simplify by doing my distributive property over here. So I distribute, this is going to give me a 4x plus 3 equals a 4x minus 8. And now I have to get the variables on the same side, so I'm going to subtract the 4x from each side. And what happens here is 4x minus 4x is 0, so I'm just left with the 3. On the other side, 4x minus 4x is also 0. I'm left with the negative 8. So I get this statement here, 3 equals negative 8, which is obviously ridiculous. This is simply just not true. And if we get a false statement like that when we're solving an equation, it means that it's no solution. Okay? If we look at number 2, I want to do the same thing. I want to simplify and then solve. I simplify by doing my distributive property. So over here I can distribute. So I've got 2x minus 1 equals a 2x minus 6. When I distribute the negative 3, that gives me a negative 3x minus 15. And now on the same side where I distributed, I can combine some like terms. So that's going to give me a 2x minus 1 equals a negative x and a minus 21. And now I've got to get the x values on the same side, so I'm going to add the x to each side. Always take care of your variables first. It just makes things simpler. We get a 3x minus 1 equals a negative 21. And now I have to add that 1 to each side. So I add the 1 to each side. So I end up with a 3x equals a negative 20. I divide each side by 3. And I find out that x equals a negative 20/3. And I can just leave that as a fraction. That's fine. Okay? If I take a look at the next one is a quadratic. And when we're solving a quadratic, I can't just simply undo operations here. I have to solve by either factoring, completing the square, or my quadratic formula. I always check factoring first. I build a bridge, two numbers that multiply together to give me a 12, but add together to give me a negative 7, or a negative 4 and a negative 3. If I can come up with those two numbers, that means this thing can be factored. I can use my shortcut because there's a 1 out front. That means this is going to factor into an x minus 4 and an x minus 3. And now I set each factor equal to 0. I do the x minus 4 equals 0. I do the x minus 3 equals 0. And I solve each. I add the 4 to each side. So I find out that x equals 4. And then I do the same thing over here. I add the 3 to each side. And I find out that x equals 3. And those are my two answers. Okay? The 4 and the 3. In number 4, I would start off the same way. I'm going to build a bridge, two numbers that multiply to a negative 1 but add to a positive 4. And really, this is not going to happen. There are no two such numbers. So this one, I either have to go to my quadratic formula or completing the square. Remember, completing the square is a good option when you have an a value of 1 and a b value that's even. And if I look at my a value, it's 1. If I look at my b value, it's even. So this is a good candidate for completing the square. So that's what I'm going to do. I'm going to add the 1 to each side. Remember, with completing the square, we want to choose our own c value. So I got to create space by moving that 1 over. And now I pick my c value, do b divided by 2, and square it. Let me put that off to the side over here. I'm doing the b value, which is 4 divided by 2, and squaring it, which is 2 squared, which is 4. Okay, so that's the thing I want to put in this blank space, a plus 4. Whatever I do to one side of the equation, I have to do to the other side of the equation. So I'm adding 4 to each side. And now I can factor this thing. The x squared plus 4x plus 4 factors into an x plus 2 times an x plus 2, which is an x plus 2 squared. And it's all equal to 5. Now I can take the square root of each side. Remember, when I take the square root of each side of an equation, the root and the exponent cancel each other out. But I have to do plus or minus this square root. Okay? So I do plus or minus the square root. Now I can subtract the 2 from each side. And I write my answer this way. I say x equals a negative 2 plus or minus the square root of 5. And that's it. And those are my two solutions, the negative 2 plus the root 5 and the negative 2 minus the square root of 5. Okay? If I look at this one, there's two ways to approach this. Probably the easiest way is to just take the square root of each side. If I take the square root of each side, that's going to be x. Once again, when I take the square root of each side of an equation, I've got to do plus or minus. So it's got to be a plus or minus 8 here. And those are my two answers. The other way to think of it is to think of it in terms of factoring. If you think of it in terms of factoring, you're less likely to forget the plus or minus. I would subtract the 64 from each side. So we've got x squared minus 64 equals 0. I can solve by factoring. That's a difference of squares. It factors into x plus 8 and x minus 8. and then I can set each factor equal to 0. Okay? So I'm going to get the same two answers. It's a little bit longer, but again, I won't make that mistake of forgetting the plus or minus. So just remember the plus or minus when you take the square root of each side of an equation, and you'll be fine just fine. Okay? If I look at number 6, again, I can check to see if it's going to factor. I build a bridge, two numbers that multiply to a negative 5, but add to a positive 3. It's not going to happen. There are no two such numbers that would meet those conditions. So here I want to go to either completing the square of the quadratic formula. I see that my a value is 1, but my b value is not even. I've got an odd value. And so completing the square is going to cause some fractions. So I'm going to go to my quadratic formula. So do the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. And I start plugging stuff in. The opposite of my b value is a negative 3, plus or minus the square root of b squared minus 4 times a, which is 1, times c, which is a negative 5, all over 2 times a, which is 1. So that's a negative 3 plus or minus the square root of 9 plus 20, all over 2. That's a negative 3 plus or minus the square root of 29 over 2. And now I look to see if this thing's going to simplify at all, to see if there's any perfect squares divided evenly in 29, but there's not. So that means my answer is just this guy. Okay, and really, again, that's two answers. It's the negative 3 plus the root 29 over 2, and the negative 3 minus the root 29 over 2. Okay? If I look at the next one, we want to complete the square. Remember, completing the square is just the act of filling in that blank space to create a perfect square trinomial. So for this one, I take the b value divided by 2 and square it. So I do b divided by 2 and square it, which is 3 squared, which is 9. Okay, so for this first one, it's a plus 9. And really, that's all it's asking for. You can check it by factoring. So if we checked it by factoring, you would build a bridge and factoring, and you'd find out that it factors into an x plus 3 and an x plus 3, which is x plus 3 squared. And that's how we can check to see if this is a perfect square trinomial. For the next one, I do the same thing. I do the negative 5 divided by 2 and square it. So that's negative 5 squared, which is 25, and 2 squared, which is 4. So there's going to be a plus 25 fourths. Okay? And really, that's what I'm looking for here. That's my answer. Completing the square is just the act of creating that. But again, if you were to factor this or check it by factoring, you'll find out that this factors into an x minus 5 halves squared. Okay? If I look at the next one, we want to match the power of I with the simplified version. So we just want to simply convert each of these to the simplest form of I. Remember, we never want to have I raised to a power, because remember this pattern exists where I to the first equals I to the second power is negative 1, I to the third power is a negative I to the fourth power is 1, and then that pattern repeats. So if I just keep counting in this pattern, I to the first is I to the second negative 1, I to the third is negative I to the fourth is 1, I to the fifth, we'd be back to the I to the sixth would be a negative 1, I to the seventh would be a negative I, and I to the eighth would be a 1. So remember, that pattern just keeps repeating. I, negative 1, negative I, 1. I, negative 1, negative I, 1. Okay? For number 13, I want to simplify this. If I've got the square root of a negative 100, you can break it up this way and say, okay, 100 is a perfect square, and that's fine, times a negative 1. Then take the square root of each. The square root of 100 is 10. The square root of a negative 1 is I, so it's 10I. All right. The other way to think of it is just remember the negative comes out as an I, the square root of 100 is 10, and you're done. All right. For number 14, I'm subtracting these things. And I can just change this to adding the opposite if I'd like, so I make less mistakes, so I'm going to change it to adding the opposite. And I'm just combining like terms. The 3 and the negative 5 gives me a negative 2. The negative 4I and the positive 6I gives me a plus 2I, and that's it. Okay, I don't have any powers of I that I can simplify. I'm just combining like terms. I'm subtracting the two binomials, and that's it. If I look at number 15, I want to solve. So to do this one, I have to take the square root of each side. Remember, when you take the square root of each side, you have to do plus or minus. So it's going to be x equals plus or minus. Well, the square root of a negative 16, the square root of 16 is 4. Since it's a negative, it's going to be 4i. Okay, we have to bust out those imaginary numbers when I take the square root of a negative. Okay. In number 16, I've got a couple options here. I can try factoring, which is not going to work. So then I can either go to completing the square or the quadratic formula. This one's a good candidate for completing the square. I would subtract the 18 from each side. So that's going to give me an x squared plus 8x with a little bit of space equals negative 18. And now I have to fill in the blank b divided by 2 and square it. It's going to give me a 16. So I have to add 16 to each side. And again, I'm just doing b divided by 2. I'm doing 8 divided by 2 and then squaring it, which is 4 squared, which is 16. That's where I'm coming up with that. And now I can factor this thing. This guy factors into an x plus 4 squared equals a negative 2. Now I can take the square root of each side. So I've got x plus 4 equals the square root of a negative 2. Again, because I did the square root of each side, I've got to do plus or minus. I can take the I out because of that negative. The root 2 is still trapped. And now I subtract the 4. So I subtract the 4 from each side, and I find out that x equals a negative 4 plus or minus I root 2. All right? And those are my two answers. I'm going to do this one more time. I'm going to do the quadratic formula. So I do the opposite of b plus or minus the square root of b squared minus 4 times a, which is 1, times c, which is 18. And really, just to show you that either way works, it'll give us the same answer no matter what. So I'm going to plug this guy in. So let's see here. I've got 4 times the 18 is going to be a 72. The 64 minus 72 is a negative 8. So I've got negative 8 plus or minus the square root of a negative 8 all over 2. Really, the only difference is there's going to be a little bit more simplifying involved. Let's get that guy over. When I do this, I can break that negative 8 down into a 4 times 2 times negative 1. I'm going to have to do this on the next line. So that's 4 times 2 times a negative 1. And now as I continue to simplify that, that's a negative 8 plus or minus 2I root 2. And now everything's divisible by 2, so I have to divide each. That's going to be a negative 4 plus or minus I root 2. And there I am back at the same answer. Okay? So either way, either completing the square or your quadratic formula for that one.